Welcome to 6.4 Vectors, Dot Products, Day 1. These are the objectives for today's lesson. These go along with the notes that you were handed in class. I'm going to work through the examples so that you can see how they're worked. Sometimes that's a little better than looking on a notes page. A dot product is a scalar. A dot product is a scalar. It's when you multiply two vectors together. So when you multiply two vectors together, the result is going to be a scalar. The dot product is a scalar, a number. And there are two ways to do the dot product. One way is to calculate the dot product by taking the magnitude of each of the vectors, A and B, the magnitude of this vector, and in this diagram it just has the one things, but that means the magnitude of A. This is the magnitude of B. Multiplying the magnitudes together times the cosine of the angle between the two vectors. So what you would be given then is either the component form of a vector A and the component form of B and then the angle in between, and then you would use that to find the dot product. So for instance, an example would be if I had A, dot product A, or A was negative 3, 4. B, vector B, was 4, 5. And then the angle between is 75.53 degrees. All right, so you would find the magnitude of A, which is 9 plus the square root of 9 plus 16, which is 5. And then you'd find the magnitude of B, which is 16 plus 25, which is the square root of 41. And then the angle, so you would say A dot B is equal to 5 times the square root of 41 times cosine of 75.53, and in your calculator that is approximately 7.999, which is essentially 8. Okay, or the other way to do that is to just simply take the dot product of the component vectors. So for instance, if we have the same vectors, negative 3, 4, and 4, 5, then to find the dot product, this is A and this is B, so to find the dot product, what you do is you take the x's and multiply them together. So you have negative 3 times 4 plus, and then you multiply the y coordinates together, 4 times 5. So you have negative 12 plus 20, which guess what is 8. So whether you do it using the angle between or you use it with the vector, that's what it is. And on the notes page, I worked several other examples, and you'll be able to look at that if you had, say, 4, 5, dot 2, 3. And you'll notice that the answer is not a vector, it's a scalar. So I would have 4 times 2 plus 5 times 3. I would have 8 plus 15, which is 23. So the dot product is a scalar. It's not a vector. So here are a couple other examples. You can see here in this first one using the angle in between the vector and then the two vectors, and then multiplying it times the magnitude and getting about 66. Or by just using the components of the vectors that are given, multiplied out in 66. So they are the same. They are the same. And then notice here on this particular one, this was negative 6, which you would have seen on the component anyway, because this vector right here is negative 6, 8, right? And this one is 5, 12. So that's where they get that, and that's what this means down here. Now, when the dot product of two vectors is equal to 0, what that means is that the angle between them is 90 degrees. Okay, I keep hitting it. 90 degrees. That's why I keep shaking it. 90 degrees, right? So they're at right angles to each other. This is called being orthogonal. Two vectors that are at 90 degrees with each other or are perpendicular to each other, right, are called orthogonal. And their dot product then would be equal to 0. So if their dot product is equal to 0, you say that it is orthogonal. And then there's an example here of what that looks like. These are a list of the properties of the dot product. You don't really need to memorize these, but it's kind of a one-stop place for all of the properties. Number 1, for instance, is the formula that we talked about to find the dot product using the angle in between the two vectors and then the magnitudes. This one is a commutative property. It means that the dot product of u dot v is the same as v dot u, which means it still is going to be a scalar. If it's u dot v equals 0, then the two vectors are orthogonal. Of course, 0 dot 0 is going to be 0. Now, 5 and 6, I'd like to work through, because this says the magnitude of v squared is equal to the dot product of v dot v. Okay, so number 5, I want to find, I've got v. V is equal to 2, negative 4. All right, so if I did v dot v, that would be equal to 2 times 2 plus negative 4 times negative 4. This would be 4 plus 16, which is 20. Okay, and then we want to find the magnitude of v, which is the square root of 2 squared, which is 4, plus 4 squared, which is 16, which is the square root of 20. But it doesn't say the magnitude, it says the magnitude squared. So the magnitude squared is going to be the square root of 20 squared, which is 20. And so, yes, you can see that v dot v is equal to the magnitude squared. And so that's showing number 6. No, excuse me, number 5. Okay, number 6 says that a scalar, a, times the dot product is the same thing as taking a times u first and then dot v. Okay, so if we let a be, let's say, just 2, and we already know what u dot v is, all right, so I would do a, 2, times u dot v, which will be or multiply the exponents, so negative 2 plus negative 12, okay, and that is 2 times negative 14, which is negative 28. That's what this side is. Over here, if a is 2, this would be 2 times v, which would be negative 2, 6. Times u. Sorry, I did the right thing. I said the wrong letter. And then v is 2, negative 4. Okay, so then the dot is negative 4 plus negative 24, which is negative 28, and they equal each other. So that one is also shown. So number 7 would be a good one to show in your notes. On the notes, I had it listed on showing properties 5 and 6. You might want to also do 7. All right, so the next objective is to find the angle between two vectors. And we've seen this before because this was the original dot product equation that we used. It's written a little differently, but what we had was A dot B was equal to the magnitude of A times the magnitude of B times the cosine of theta, which is the angle in between. If you solve for cosine theta, you end up with this equation. And this is dot product on the top, but it's multiply on the bottom. Dot product on the top, but multiply on the bottom. So it's u dot v on the top and here. All right, so this is looking at to see what the angle is in between. So for instance, if we let u equal 4, 3, and we let v equal 3, 5, I picked a couple of easy ones, and then find the angle between the vectors. And so what I like to do is I go ahead and do everything over here. Find the magnitude of u, find the magnitude of v, find u dot v, and then write it into the formula. So the magnitude of u is 16 plus 9, which is the square root of 25, which is 5. The magnitude of u is 9 plus 25, which is the square root of 34. And u dot v is going to be 4 times 3 plus 3 times 5, which is 12 plus 15, which is 27. All right, so then I'm ready to write my formula. Cosine theta is the dot product, which is 27, over the magnitude of u, which is 5, times the magnitude of v, which is the square root of 34. And when you do the second cosine, I think in my notes I wrote it like this: arc cosine of 27 over 5 times the square root of 34. That is approximately 22.2 degrees. And that's the angle between the vectors. On your notes page, I worked a couple more problems. I think that may be on the next screen. Here are some examples on how to determine the angle between the two vectors. One thing that you need to do, first of all, is to find the dot product. Because if you find the dot product and it is 0, then you already know what the angle is. So you don't need to do the magnitude or find the rest of that because you already know what it is. So let's work A. B and C are the ones that are worked out on your notes page, and you can take a look at those. But I'm going to find the dot product of u, so I'm going to find u dot v, and that's going to be 3 times 4, which is 12, plus negative 1 times 3, which is negative 3. 12 minus 3 is 9. So it is not orthogonal. It is not a right angle. Then the next thing you want to do is go ahead and find the magnitude of u. The magnitude of u is going to be 9 plus 1, which is the square root of 10. And the magnitude of v is going to be the square root of 16 plus 9, which is 25. The square root of 25 is 5. So then when you go to find the cosine of theta, it will be the dot product, which is 9, over 5 times the square root of 10. And so theta is going to be the arc cosine of 9 over the 5 square root of 10. So I took a little break and got my calculator out, and theta is going to be 55.3 degrees. And if you were to graph those two vectors, you would see that that's pretty close. The ones with the fractions are done on your notes page, but in particular on C, finding the dot product of v and u, I can't even say it right. I'll write it again. V and w, the dot product of this is equal to 4 times 2/3 plus 3 times negative 8/9. Okay, so I have 8/3 minus 24 over 9, which reduces to 8/3, and so that equals 0. Well, if the dot product is 0, I know that this is orthogonal, which means that theta is 90 degrees, and I'm done. So this one has some fractions in it, but since I did the dot product first, then I did it just right. Okay, so there'll be an assignment in class working some of these types of problems, and you shouldn't have any trouble with them, and I will see you back in class.